Today we're going to continue working with exponential growth and decay, mostly growth because we're going to be dealing with a specific kind. We're going to talk about compound interest. And so the compound interest formula is very similar to the other formula, except we add in this n, where n is the number of compoundings. Okay, so in other words, if you just had basic interest, your money would go in at the end of the year. The interest that you earned on the account would go in at the end of the year. But if I have like a number of compoundings, then it goes in earlier, so my interest can earn interest faster. Okay, so like if I go quarterly, that's every 3 months, right? So n would be 4. We would plug a 4 in there where the n's are into our equation. Or if we were monthly, then n would be 12. Or if we were daily, n would be 365 or whatever it is. Okay? And so at the end of each of those periods, the interest would go in, and so we earn a little bit more money. Not a lot, but a little bit more money. Okay? And again, I told you before, it takes money to make money. So the more money I have to start with, the more money I'm going to make on interest. Okay? So let's say I have like $1,000 and I'm going to earn 3%, and it's going to compound quarterly, which means that n is going to be 4. And then let's say I want to know what the account is in 5 years. Okay, what's going to be in the account if I don't take any money out and I don't put any money in. Okay, so what that looks like then is we'd say, all right, well, the amount in the account equals 1,000, which is my principal. That's what the P stands for. And then remember, I have to turn my percent into a decimal, so that's 0.03. And then I've got divided by 4, because that's what n is. And then I got 4 times 5. Okay? So what I'm going to do is I'm going to use my calculator, and I have to do this part first. So I'm going to go 0.03 divided by 4, and then I'm going to add 1 to that. Okay? And so that gives us 1,000, and then this is all 1.0075. And then this is going to be to the 20th power. Okay, so 0.03 divided by 4 was 0.075. I added 1 to that, and I get this whole thing. Now I'm just going to take that to the 20th, so I'm going to hit caret 20, and that gives me 1.16118, blah, 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 blah. I'm just going to leave that in my calculator and take that times 1,000. So I hit times 1,000 on my calculator, and that means that at the end of 5 years, all have made $161. Okay, that's compound interest in a nutshell. I'll do one more example, and then we'll do continuously compounded. All right, so let's say I've got $500, and we're earning 2.5%, and it's compounded monthly. So n is going to be 12. And let's say I want it in 10 years. I'm going to leave it in there for 10 years. Okay, so again, our formula is amount equals the principal, whoops, not equals, and then 1 plus the rate over n to the n times t. So we're going to have 500, and 1 plus 0.025, 2.5% is a decimal, is 0.025, and then we're going to divide by 12. And so now we're going to take this 12 times 10, my n times my t would be 12 and 10. So again, I have to do this first. So on my calculator, I'm going to do 0.025 divided by 12, and then add 1 to that, and I get 1.00208, blah, blah, blah. I'm going to just leave that in my calculator, and that's going to be to the 120th power. So I hit my caret button, and then 120, and that gives me 1.28369, blah, 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 blah. Okay? So I'm going to take that times 500. And that gives me 641.85 if I round. So in 10 years, I made $141. Just having my money sit there. Okay? So that's compound interest. Now, continuously compounding is another type of compounding where it just As soon as it's made, it's put in the bank, okay? And so we use a number called E. It's Euler's number. And we use this formula. The amount in the account is the principal times e to the RT. Okay? E is found, you can find an e to the x button right next to the 4. It's in blue. And I'll try to have a picture for you. Well, I'll show you later, but it's, if you look at your 4, there's an LN button, and then above the LN in blue it says e to the x right there. Okay? And so you use that button. So let's say I've got my $500 and it's continuously compounded and I'm earning 2%, and I'm going to keep it in there for 4 years. So I would go 500 and then, and then e to the 0.02 times 4, just like that. Okay, so I'm going to figure out what that is. 4 times 0.02 is going to be 0.08. So I'm going to go e to the 0.08 and then times 500. So I'm going to go, on my calculator, go second e to the x 0.08. That gives me 1.083, blah, blah, blah. And I'm going to take that times my 500. And it's 541.64. So continuously compounded at a little bit lower interest rate even, in only 4 years I made more money, didn't I? I made about the same amount of money as I did in 10 years, not continuously compounded, okay? So, but that's how you do that. That's the PERT formula, principal times e to the RT, and you just plug in your rate and your number of years. That's your exponent for the e, and then take it times the 500. That should take care of it.